Okay, first question. We're being asked to find the total flight time of an arrow that's launched. So the first thing to do, of course, is to draw a quick little diagram. Here's the velocity of the arrow being launched at 70 meters per second. Here's the horizontal component of that, 70 cos 50, and the vertical component, which is equal to 70 sine 50. So, if we're considering the flight time, best way to attack this problem is to consider only the vertical component of the motion. We'll consider how long it takes to reach the top of its flight, and then double that time. That'll tell us how long it takes to come back down again. So, considering only vertical motion, we list everything we know. Here's initial velocity, 70 sine 50, which is 53.6 meters per second. Acceleration is negative 10. Final velocity is 0 when it reaches the top of its flight. And the times are unknown. So using v equals u plus at, we find that the time it takes to reach the top of its flight is 5.36 seconds. So the flight time equals double that, the time it takes to reach the top and then back down again. So flight time is 10.7 seconds. So there's 3 marks for that question. The distance of the target from Alex, so how far does it travel? How far does the arrow travel in that 10.7 seconds? So horizontal velocity is 70 cos 50 from the diagram here, so 45 meters per second. And the time it takes to travel that distance, 10.7 seconds. So velocity equals displacement over time, 45 equals displacement over 10.7. So the displacement is velocity times time, 482 meters. Okay, 2 marks for that question. Question 6, the net force on the arrow at the top of its flight. When the arrow is at the top of its flight, the only force acting on it is gravity, which is the only force acting on it through the whole of its flight. So at the top of the flight, net force equals mass times acceleration. Mass of the arrow, 0.1 kilograms, that was given to us in the question, times gravitational force. So net force is 1 Newton down. Make sure you specify a direction. The force is a vector, of course. And state the effect of air resistance. How would air resistance change the answer to this question here? Well, the distance would be less. This is only a 1 mark question, so you really only need to make one short little statement. So if air resistance was included in the calculations, the distance would be less.